Okay, welcome back, YouTube. Here we are for another video of the making a computer with transistors. Another little piece of the puzzle, so stay tuned for this one. Okay, so the next piece of the puzzle is the latches. We're going to build a couple of different latches. This is the thing that computers use to store data. First thing is an SR latch. This is the first circuit we're building. And you can see here, where's my screwdriver? Two resistors here, two resistors here, two transistors, and two switches. And so, okay, so like my explanation of this is when you turn it on, it's going to randomly, one of these is going to be open and one's going to close randomly. So say this one is closed and this one is open. So whenever we close this push button switch here, it's going to turn off this transistor because it's going to ground. It's going to put the base at ground. So this transistor is going to turn off, which means the 5 volts, some portion of it with this, is going to make it through these two resistors to the base and turn this one on. So when this one turns off, then the LED, where do I have the LED actually? To ground. So I have the LED from here to here. I should have drew it on there. So whenever this opens up, the LED will turn on. And then when this transistor turns on, the LED is across here. So when this turns on, then essentially this is ground and this is ground. So this LED is going to turn off. Then when we push this switch, that's going to put ground on the base. That's going to open this transistor, which will turn this LED on. And that will allow some power to go, some voltage to go to this base, which will turn it on and turn this LED off. And that's how it'll flip back and forth. So let's turn it on here. See what we got. 5 volts. Okay, so I got my two switches there that you can see. And there's a set and a reset. So now we can set an output to something and we can reset it. It latches. Very basic. We're not going to use this on our computer, but this is just a basic latch. Okay, the next thing I built is an SR latch with a NAND gate. Basically the same thing, but we're going to use NAND gates. Okay, so this is really ugly, what I drew here, because I originally drew it with the LEDs here. Then I figured out I had to add a buffer at the end because these LEDs weren't turning on. Once I added a buffer, so now once I did this, I just scratched these out and kind of drew this extra transistor here and did a really crappy job of drawing it. Sorry. Extra transistor here for the buffer. Here's my two LEDs that you see right here on the circuit board. So that's what I did here. You can see I got 4 transistors for each side. So these two are just the extra buffer that the LEDs are going to. They're these two here. And you know, this is really how it is. And I think these are just buffer. Actually, these are inverters, right? Inverters. They're set up like inverters. But the first two are just buffers. And so this is really what it is. It's 2 NAND gates, 2 inverters on the outputs, and 2 buffers. We got set and reset. So when I press set, it's just a buffer. So I take this and this is not. So this is a 1. And so then this is a 1. When I press this one, this is a 1. So this is a 0. This makes this a 0. And that's how it flips back and forth. And then these 2 inverters just invert the output. They make it opposite. But so let's see. This is the same thing though. This is just an SR latch built with NAND gates. Just like so. You can see what I got. Set, reset. Set, reset. Same thing as the first one. Just a way to store a bit of information. I can set it, and that's a bit of information, and it stays there until I hit the reset button or until I remove power. So the next latch I built is a gated SR latch. So the only difference I did from the previous latch was I added 2 more NAND gates, tied 2 of their inputs together and made that the enable. I still have a set and reset with my output. Same thing. You can see the circuit that I built here. See, all I did was, these were the buffers, but I just added another transistor to make this a NAND gate, and this is a NAND gate. And here's the 2 NAND gates from before. And then the output inverters. So yeah, so this is my gated SR latch, and so what it does is kind of a cool thing. Let's turn the power on. And so it's going to do kind of the same thing. I can set a bit and reset a bit, but I have these extra NAND gates. So unless this enable is high, these are never going to work. So I tied these 2 together to an enable pin. You can see that this red jumper wire here ties these 2 bases together, and then it comes here to this switch, it comes here to this resistor. And right now I have it tied high. So the enable is tied high. So this will work as normal right now. I can set it and reset it. But now what I can do is set it. Now if I remove my enable pin, look, nothing happens because these 2 NAND gates aren't made, because one input from both of them is low. So these are nothing's ever gonna change here. So now it's set permanently. That little bit of information is permanently set in it until I either remove power or, put the enable resistor back in. Let's see if I can do it. Put the enable resistor back in. And now I can reset it, set it, reset it, set it. I can get my bits set, remove my enable, and nothing works again. See? So I can permanently set that bit. It's kind of cool, right? So that's the gated SR latch. So we're going to do one more latch type in this video of latches. Okay, so here's the next circuit I built. I built what's called a data latch. And if you look at the last one, the gated SR latch, it's pretty much the same thing, except I added an inverter here. And now instead of having a set and reset, we just have a data input, 1 input instead of 2, because I tied this 1 input directly to this NAND gate. This one goes through an inverter to this NAND gate. So now what happens is whenever the enable pin is installed, which is this right here, this resistor right here, whenever the enable pin is active, high, and I set it, right? Or when I release it, resets. Set, reset. Okay, so now, as you can see, I can put some data in, and then I can remove the enable pin, and when I release it, the data stays there. See, because these 2 gates, these 2 AND gates or NAND gates, are never going to be made because the enable pin is removed. So my data stays. See? And if I put the enable pin back in, it resets. See that? And now I can go back to changing the states. Data going in, put some data in, remove the enable pin, and it stays. Okay? So that's called a data latch. Okay, YouTube, that is my latch video for my transistors to building a computer out of transistors. So my next video is going to be all about the flip-flops. So I guess we'll use some of this information that we learned about the latches to build flip-flops. I was going to build one more latch circuit, which is to put the clock signal in a data flip. Well, it's a data flip-flop, so I guess that's for my next video anyhow. But I was going to try to squeeze it in the back here, but sorry about that. I was going to try to put that one at the end of this video, but I couldn't get it working. So I'm not sure why. I'll have to figure out why I couldn't get that working. So that'll be on the next video. So thanks for watching. Stay tuned for the next one. Don't forget to like, comment, and subscribe, and everyone have a great day. Bye.